Hello everyone. Today we're going to talk about the chemistry of indigo and how we do tie dyeing using indigo. You know, indigo is one of the most ancient dyes that was first extracted from a tree called the Indigo tinctoria tree, found in abundance in India and going back several thousand years. And it was one of the best exports for the country at the time. Of course, with the Industrial Revolution, scientists learned how to synthesize indigo. So this laborious technique of extracting it using the tree is no longer practical, and we could actually make this compound in the lab relatively easily. I'm not going to get into the synthesis of indigo, but I'm going to show you what the structure of this compound looks like. So I know this is a beginner's course in chemistry. You're not going to really recognize or know much about chemical structures or functional groups, but it is a pretty large molecule. And then, as you can see, or if you might learn in lecture, you've got a couple of functional groups, such as the carbonyl or the ketone, and here you have an amine, and then you have the same thing on the other side, except the nitrogens are diagonal and the carbonyls are diagonal. Okay, so this is the structure of indigo. So in the lab, what you're going to do, you're going to have to take this compound, reduce it so that it turns into a soluble dye. Okay? As is, this compound is insoluble in water, so you can't just take it and use it against a textile fiber to dye the material, because it will just get washed off, and it's also water insoluble. So the way to do this is convert it into a soluble dye, and the way you can do that is by treating it with sodium dithionite, which is Na2S2O4, sodium dithionite, and that's in your textbook. You can review it. And this compound is a reducing agent, and will reduce this indigo into a soluble dye. So we're going from an insoluble dye to a soluble dye. So what does the structure of the soluble dye look like? So we're going from an insoluble indigo into a soluble dye. So in this way, the compound becomes water soluble, and then at that point, you can bring it into contact with the desired fiber. And what happens is that the dye, the soluble dye, actually interacts with the fiber in such a way that it will penetrate through the interstices of the fiber, and through chemical reaction and physical entrapment within the fiber, the compound basically, the material gets dyed, and then this soluble dye, by the way, has a color of yellow. it's yellow, and of course indigo is the color of indigo, very, very deep blue, right? So what you're really doing, and I'm going to show you in the lab, is that you will allow the fiber to come in contact with this yellow soluble dye, and then you soak it in there for a little bit, and then when you take it out, and expose it to air, that the insoluble dye goes back to, the soluble dye goes back to indigo upon oxidation in air, and the color of indigo will resurface, and the material will have the color of indigo, and then you wash the excess off in water, right? So this is in a nutshell what we will be doing in the lab, and you could use all kinds of fiber to do tie dyeing, but the best one that really interacts with this indigoid dye is cotton, right? So I have a piece of cotton here which I'm going to use for tie dyeing, okay? So let's go to the bench and do the chemistry. Okay, so here is what we're going to do for preparation of the indigoid dye. And the first thing is to convert the indigo into a soluble indigo, right? So the first thing is, as you can see the setup, this is a test tube. I'm going to be putting in the sodium hydroxide, so it's 10 normal. And the temperature of this bath is around 50, that's exactly where I want it. So I can lower the temperature a little bit. So the procedure says use 5 milliliters of this solution. That's good. And it says add this to 0.1 grams of indigo. So I'm going to weigh 0.1 grams of indigo. That's exactly 0.1 grams of indigo. You can see how deep blue the color of indigo is. I'm just going to add this to the test tube. And add this 5 ml sodium hydroxide solution. I can take this out so you can see there's no solubility yet, right? The indigo is suspended basically in the basic solution, no solubility yet. Then it says add 10 ml of water. Okay. You can see there's still no solubility. The indigo is still suspending in the aqueous basic solution. Now we need to add 4 grams of sodium dithionite. This one you have to be a little bit faster because this compound really smells pretty bad, right? So ideally it should be done under the hood because it's got sulfur in it. So we need quite a bit of this, 4 grams. Exactly 4 grams. You can add it to this solution. And And this is the reducing agent I was telling you about. So we can now immerse this into this water bath. And as you can see, the solution is slowly turning greenish in color, right? So I really have to go in a little bit down inside the bath to make sure this is covered. So I stir this up and let this thing cook for a little bit, right? So while this is cooking, let's just take a 250 milliliter beaker, add about 100 milliliters of water. Okay, so as you can see, the deep blue color of indigo is gone, and the sodium dithionite reduced that indigo to this soluble indigo, sometimes referred to as a leucoform, L-E-U-C-O, leucoform. That's referred to as the soluble dye. If you notice, at the very top, right, you can see the blue here, right? That's where there is still quite a bit of oxygen. So at the surface we have a lot of oxygen, right? But inside the solution we have no oxygen because we're heating this thing. And just lower the temperature a bit. And this is exactly what we want, right? So the next part of the experiment says place 100 milliliter in a beaker, 100 milliliter of water inside a beaker, and this is the material I was showing you, the cotton. And I'm going to try to use a rubber band to try to make a knot here. So here is the cloth, and here is the rubber band. Let's try to make a knot, which is kind of tight. Looking something like this, right? Now, I can just either pour the whole thing out, or your instructor will tell you how much of this solution to take. I'm just going to eye measure and say, you know what, I'm going to transfer half of this and add it to this 100 milliliter of water, okay? Then place this cloth inside the beaker and let it soak. But do this quickly, because as soon as I put this in there, this thing is going to air oxidize. We can put this in and let it soak for a few minutes. And then we will take it out and wash the cloth. Expose it to air, let it get nice and blue. Maybe I can use a paper towel. Okay, so I'm going to take this cloth out very quickly, very soon, I should say, and then allow it to be exposed to oxygen of the air. I can actually, since I'm wearing gloves, I can just squeeze this and then open the cloth. You can see the cloth is yellow right now, but when it turns blue, I'm going to open this, to remove the rubber band and then wash it right away. So this is, this is the cloth, as you can see, and as we speak, the color is turning to blue, right? That's because the reduced form of indigo is now becoming reoxidized back to indigo, and that's where you see the blue color. So the color keeps intensifying more and more to the blue. So I leave this for a few more minutes. So you can see now the color of the cloth is nice and blue, the color of indigo. So at this stage I can just remove the rubber band and then quickly kind of wash the cloth, right? Because I don't want the unexposed part of the textile fiber to be exposed to any of that solution. That's pretty good. And here we go with a nice tie-dyeing of this material. You can do this on your t-shirt, you can give it all kinds of design that you like. And of course this was the part that did not get exposed to the solution. That's why it's remaining the original color white. Okay? So have fun.